This is another video in our series on solving quadratic equations. In this video, we're continuing to talk about the quadratic formula. The quadratic formula is a plug-and-play formula where you identify the coefficients of the variables in your quadratic equation and your constant, and you plug those numbers into a plug-and-play formula. Let's look at example number 1. This is a quadratic equation. The first term is x squared. It's to the second power. That makes it a quadratic equation. The first thing we'll need to do to solve this equation using the quadratic formula is to identify the coefficients of the variables. We see here that the coefficient of the x is negative 11. There's a negative in front of the 11 that makes the coefficient negative 11. The coefficient in front of the x is a 1. If it was 0, you'd have 0x squareds, and you wouldn't even see the x squared term. If it was some other number, like a 2 or a 3, you'd see that number. So that the coefficient has to be a 1. So the coefficient in front of the x is a 1. So we'll say a, because we give it a letter, represent what's the coefficient in front of the x squared. We'll say a is equal to 1. B, which represents the coefficient in front of the x term, is negative 11. And C, the constant term, is negative 42. Okay? So we're going to take these three numbers and we're going to place them into the quadratic formula, which is a plug-and-play formula. Just plug the numbers in where they're supposed to go. So the negative 11 goes up here at the front where the b is, and also inside here where b is being squared. Notice that this is negative b in the formula, which means that you want negative 11, because b isn't 11, it's negative 11. The quadratic formula is going to give us two answers. One answer for positive, negative b plus this square root, and the other answer for the negative b minus this square root. So that means that quadratic equation has two answers. X will equal two different things. We're being asked to solve for x, meaning to find out what value you could plug in here for x into this equation, and it would be equal to 0. By plugging into the quadratic formula, we're going to get two different answers. One when we use the formula with a plus, and one when we use this formula with a minus. So let's look at negative 11. Because b is not 11, it's negative 11. Well, what's negative 11? This is negative times negative is what this is. You want to multiply negative times whatever's inside the parentheses. And what's inside the parentheses is already something negative. So negative times negative is positive. So this term out front turns into a positive 11. Negative turns positive. Inside the square root, we have a negative 11 being squared. Well, that's negative 11 times negative 11. That's what squared means. So again, negative times negative gives you a positive. So this also gives you a positive number. This last part inside the square root, we've plugged in c here and a there, and it's negative 4, negative times negative 42. So again, negative times negative gives us a positive. So this term also turns into a positive number. So you have this positive number added to that positive number, which gives us 289 inside the square root. Now because this is the square root, we probably want to investigate, is this potentially, this 289, is this equal to something being squared? And come to find out it is, because 17 times 17, 17 squared, 17 times 17 is equal to 289. Well, the square root and the squared, those are reciprocal operations. They cancel each other out. By squaring something and then square rooting it, you just get the number back. So 17 squared square rooted is just 17. This operation here means that there's two different things we're going to do. We're going to do it one time, calculate one answer, with a plus here. And then we're going to come back and calculate a completely different number using a minus here. So we're going to get two answers. 17 squared turned into a 17, and this plus minus, if it's plus, you do 11 plus 17. 11 plus 17 is 28 over 2. Now you got to calculate it the second time with a minus, because that's your other answer. It'd be 11 minus 17. So 11 minus 17, you have more negatives, 17 negatives. You get more negatives than positives. So that's going to give you a negative answer. So 11 minus 17 is negative 6. And negative 6 divided by 2 is negative 3. So our two answers, the two numbers that we could plug in here, put into our original equation, our quadratic equation, if we calculated this equation with 14 squared minus 11 times 14, that would equal to 0. Also, if we put a negative 3 in there, negative 3 squared minus 11 times negative 3, and then take away 42, that would also give us 0. So either one of these two numbers here is a solution to this quadratic equation. And notice here that 28 divided by 2 was 14. That's where the 14 came from. I had to reduce that fraction. Okay, let's try classwork. It looks just exactly like this problem. You may want to go back and watch this example over again. Here's your problem. You're going to identify what is A, what is B, and what is C, and you're going to plug them into the quadratic formula, and it's going to give you back two answers. X could be two different things. So pause your video, go back and rewatch example number 1 if you need to. Pause your video, and then try this problem. Then we'll come back and compare answers. All right, let's look at what I got. Okay, so I went to this website right here, and all you have to do, this is a very nice website, is type in that quadratic equation, and it gives you back all this information. It shows you the problem you were doing, what is A, what is B, and what is C. Then it takes those three numbers and plugs them in to the quadratic formula. And it gives you back a reduced answer, what is X, and what is the other number that could be X. And either one of these two numbers, if you was to evaluate this equation, meaning if you was to take either one of these two numbers and put it in this equation for X, you would get back to solving this equation is equal to 0, because these two numbers solve this equation. All right, let's look at another example. Oh, another classwork. Okay, so same thing over again. Plug in your coefficients, A, B, C, and solve for the two different possible answers that X could be. Pause your video, and then we'll compare answers. All right, let's have a look at my answers. Okay, again, from this website, right here, I typed in that equation, and it gave me back this information about this equation. The A, the B, and the C. A, B, C. A is a 1, because there is no coefficient out in front. B is a minus 7, because it's not just 7, it's minus 7. Plug those numbers in to the quadratic formula. This is negative minus a negative 7. And it resulted in these two numbers. Notice that this is a number. It's a very unpleasant looking number. It has a square root in it. It's not something you could easily put your finger on and say, I know where that is on a number line. It's between 2 and 3. You don't know where it is because it's got a square root, which is very hard to calculate without using a calculator. But it is a number, and so it is the answer. These are the two answers, even though they're not very useful answers because it's hard to know exactly what numbers those answers are. All right, now let's look at another example. Example number 2. Okay, same thing over again. We're going to use the quadratic formula to solve for X, meaning we're going to find what value of X would make this equation here true. Well, notice that this equation here, it is a quadratic equation because the first term has an exponent of 2. x squared. So this is a quadratic equation, but it has no middle term. There is no term in the middle here that tells us how many x's there are. Well, if there are no x's, the mathematical symbol for there aren't any x's in the middle here means there are 0 x's in the middle here. So now we have this equation in the correct form to find our a, our b, and our c. Notice that you cannot obtain the a and b and c unless you put the equation into this form. It has to be exactly like this before you can take out which one's a, which one's b, and which one's c. So there was no middle term in here. We had to put a middle term in to find out what our b was. And it has to be the highest exponent first, x squared. The variable with no exponent in the middle. And at the end, the constant. In that exact order, with a 0 on the other side of the equal sign. Then we can use the quadratic formula and identify our a, our b, and our c. So, quadratic formula, the plus and the minus terms, we're going to use a is 4, b is 0, and c is a minus 121 because there's a minus sign in front of the 121. So plugging into our formula, b is 0, and again here b is 0. This is minus negative 121. So it's negative times negative. Negative times negative is positive. So inside of the square root, we're going to get a very large number, 1,936. And its two answers is either plus the square root or minus the square root. That's our two values for x that will solve this equation. So we ask ourselves, is there some number squared that equals to 1,936? If there is, a square and a square root will cancel each other and we'll end up with just a number. Well, come to find out, 44 times 44 is equal to 1,936. So 44 squared equals 1,936. So the square root and the squared, those are reciprocal operations. They cancel each other out. So when you square the square root, it just goes away, and you end up with just the number 44. So you have plus and minus 44 over 8. Two different answers. One is plus 44 over 8, the other minus 44 over 8. Okay? Now let's ask ourselves, can we factor something out? Can we lower, is there something that will come out of this 44 and also come out of this 8 so that we can reduce this fraction? Well, 44 is 4 times 11. So 4 goes into 4 once, and 4 goes into 8 twice. So we can cancel the 4 against this 8 and reduce this fraction to 1 over 2. So it's 11 on the top, 11 times 1, and a 2 on the left on the bottom. So we end up with a plus or minus 11 over 2. So one of your answers is plus 11 over 2, and the other answer is minus 11 over 2. That's the two answers. If you took either one of these values and you evaluated this quadratic equation, meaning you put this number in where the x is, then this would be a true statement and it would prove that this is true. This is a solution to that quadratic equation. All right, let's look at another example. Here it is again. This is a quadratic equation. You can tell it's quadratic because the first term has a variable squared. That makes it a quadratic equation. But now we need to find our a, b, and c because we want to use the quadratic formula to solve it. Well, this is in the wrong order. It can't be in this order to solve using the quadratic formula. You have to put it in the order where the x squared comes first, the next term is the variable x, the final term is the constant, you have an equal sign with a 0 on the other side of the equal sign. That's not the way this is. The 630 is on the wrong side of the equal sign. So we're going to need to move this 630 over to this side of the equal sign so it'll be the right format to use the quadratic formula. So how do you move a 630 from one side of the equal sign to the other side of the equal sign? Well, you subtract it off of this side, and the rules are with an equal sign, you subtract it off of one side, you're allowed to do that, but you've got to subtract it from the other side as well. So we subtract it off of this side, then we have to subtract it off of this side. So we end up with 630 minus 630 equals 0 on this side. And on this side over here, we now have a minus 630. Okay, so now this is in the correct format to get our a, our b, and our c. Here's our a in front of the x squared. Here's our b, negative 165, that's in front of the x. And the constant term, minus 630, that's your c. So I'm going to put that up into this quadratic equation, quadratic formula, a, b, and c. So plugging it in, you get a minus negative, right? So negative times negative is positive. So it's going to be a positive 165 out front. Then you're going to have two answers, one with a plus here, and the other one with a minus here. Inside the square root, you've got a negative number here being squared. Negative times negative turns positive, so that will turn positive. And here, you have a minus 4 being multiplied times a minus 630. So you have a negative here times a negative there. Negative times negative turns positive. So this turns positive, and that turns positive. All right, this is a very large number here, and it's inside of a square root, and we'd like to ask ourselves, perhaps this is something squared, this large number. If it is, then the square root of something squared will cancel, and we'll end up with just a number. So, in fact, 255 times 255 is equal to that number. So we end up with the square root of 255 squared. And squared and square roots are reciprocal operations, and they cancel each other away. So you end up with 165 plus 255 and 165 minus 255. Those are your two answers. So on the positive side, you get 780 over 30. If you want to try to reduce this fraction, 30 goes into 780 26 times. So our answer, our one answer, is 26. So 26 will solve this equation. If you put 26 in for x and evaluate this equation with 26, this will end up a true story. All right, what's our other answer? One answer is 26. The other answer, 165, take away 255. Well, which number is larger? You get more negatives here than positives. You have 255 negatives. If you put these two together, you're going to get a negative number. It's a negative 90 over a 30. Well, we can reduce this fraction as well to 3, because 3 times 30 is 90. So it ends up being negative 3. So our other solution to this original quadratic equation that they gave us is negative 3. Negative 3 solves this equation, and 26 also solves this equation. Those are your two answers to that equation. All right, let's look at another example. Again, this is a quadratic equation. You know that because the first term is the variable squared. That's the biggest exponent in the problem is a squared. So it's a quadratic equation. We want to solve for x. We want to know what value of x will make this statement here true. And we're going to use the quadratic formula. Well, the quadratic formula requires that our terms here be in the correct order. It has to be the x squared term, followed by the x term, followed by the constant. But that's not what we have here. They're out of order. This term and that term need to swap positions, because x term needs to come next and then the constant term. Now notice that these two numbers are both on the same side of the equal sign. So we don't have to subtract things across the equal sign. Things are already together right here on this side of the equal sign, and we're allowed to just swap them. We'll move this one to here and this one to there. We don't have to add or subtract anything. We're just going to move their positions. This is a negative 2. You see the negative in front of it. This is a negative 2, and that's a negative 3x. So we'll just swap them around. So the negative 3x is in the middle, and the negative 2 comes on the end. Okay, now we can identify our a, b, and c, because everything's in the right order. There's a 0 on this side of the equal sign, and we can find a is the coefficient of the x squared. B is the coefficient of the x. And c is our constant term. And we're going to plug it into this quadratic formula. So a is 2, b is negative 3, and c is negative 2. Plugging it in, negative times negative is positive. Negative squared is positive, and negative times negative is positive. So we end up with all positive numbers. We have the square root of 25 on the top. Well, we know that 25 is equal to 5 times 5, 5 squared. So we have 5 times 5, 5 squared, and the squared and the square root cancel each other, and you end up with just a 5. So we have 3 plus 5 on the top, or we have 3 minus 5 on the top. So 3 plus 5 gives us 8 over 4, which is a fraction, and we can reduce that fraction because 4 divides the top and the bottom. We can get 2. Or we can get 3 minus 5 on the top. You have 5 negatives, 3 positives. That means the answer is a negative. 2 over 4. We can reduce this fraction also. It's still going to be negative, but it'll be, we can divide the top and the bottom both by 2, and we get a negative 1/2. So either one of these two numbers will solve this equation. So those are our two solutions. The two solutions, x could be 2 or x could be a negative 1/2, and it will solve this quadratic equation. All right, let's try classwork, just like the example we just did. If you need to go back and watch the example, watch that over again. Pause your video, work this problem, and then we'll compare answers. All right, let's look what I got. I went to this website right here at the bottom. I typed in this quadratic equation, and I got A, B, and C. And when it went through the quadratic formula, we got a positive and a negative, a plus and minus answer. This became the square root of 100. The square root of 100 is 10 times 10. So this becomes 10, 60 plus 10, and 60 minus 10. So when we reduce those two fractions, we end up with x is 1, x is 5 over 7. Those are the two numbers that will solve this quadratic equation. Thank you for watching the video.